Hello students, welcome to Zoology Classroom. In today's class, we are going to learn about certain topics related to muscle contraction. And those topics are muscle twitch, summation, Treppe, tetanus, and fatigue. So before entering into the topic, it is very important for us to understand how the muscle contraction takes place. So we have studied about this muscle contraction process in the previous class. In the previous video, you have seen how the muscle contraction takes place. Anyhow, once again, remind that information so that we can best understand the topic that we are going to discuss today. So in this slide, you are seeing a muscle fiber. This is a muscle fiber. And each muscle fiber is linked to a nerve fiber. You know the neuron structure? In the neuron structure, nerve cell, neuron structure, many telodendrites or many dendrites will be there. Each dendrite is a nerve fiber. Okay, each dendrite is a nerve fiber. So in the muscles, in our body, many muscles are there. In each muscle, many fascicles will be there. And again, in each fascicle, many muscle fibers will be there. Okay, muscle comprises of fascicles. Fascicles comprise of muscle fiber. Muscle fiber is a muscle cell. So each muscle cell, okay, each muscle cell is connected to a nerve fiber. What is nerve fiber? Nerve fiber is nothing but a part of a neuron. Nerve fiber is a dendrite. Okay, nerve fiber is a dendrite, and dendrite is a part of a neuron. So each neuron, okay, each neuron is having many dendrites, and each dendrite is linked to a muscle fiber. What is important here to understand is that a single muscle fiber will be connected to a single neurofiber or nerve fiber only. Okay, a single muscle fiber will not be connected to two or three nerve fibers. A single muscle fiber will be connected to a single nerve fiber only. So this is the very important thing. We should not forget this thing. And muscle fiber and this nerve fiber, both of these two things collectively called as motor unit. Okay, muscle fiber and the connected nerve fiber, both of them are called as motor unit. So motor unit is very important one. So like this, in a fascicle, many motor units will be there. Okay, in a muscle mass or in a fascicle, many motor units will be there. Each motor unit is consisting of a muscle fiber and a connected nerve fiber. And the junction between these two connections, nerve fiber and muscle fiber, is called as neuromuscular junction. Okay, neuromuscular junction. And the end part of this nerve fiber is called as motor end plate. Motor end plate. And there will be some gap between this motor end plate and the muscle, that is called as synaptic cleft. Synaptic cleft. And through the synaptic cleft only, action potential. Okay, action potential is coming from CNS, central nervous system, from the brain region. Okay, this action potential will be sent into the muscle cell through this synaptic cleft only. So this is the structure of the neuromuscular junction. So it is very important for us to understand the remaining forthcoming topics. And in the muscle contraction, three events will take place. Two are electrical events, one is a mechanical event. So two electrical events. First electrical event is that membrane potential will be changed. Okay, in this nerve fiber. In this nerve fiber, membrane potential will be changed. So when the action potential from the central nervous system is not reached this motor end plate, then what will be happening? The potential of this motor end plate will be having minus 70 millivolts. Minus 70 millivolts potentiality will be there. But when the action potential reaches this motor end plate, gradually what will happen? This this potentiality will increase. It will go up to plus 30. minus 70 to it reaches up to plus 30. So around 100 millivolts of potential will be increased. 100 millivolts of potential will be increased. And this increased potentiality will be seen in the form of a spike if we measure this potential differences with the help of a machine. We use a certain machine, we use a machine to record the heart functioning. Okay, electrocardiograph. Electrocardiograph machine will be used to measure the ECG, to take the ECG. So same type of machines will be used to measure the electrical changes or potential changes that take place in the neuron and in the muscle fiber. So first event is electrical event that will take place in the nerve fiber ending or motor end plate. So the change in this thing, the change in this potential is called as depolarization. Earlier it was polarized like minus 70 millivolts. When the action potential reaches this region, our minus 70 potential will be changed to plus 30. So this is called depolarization. Depolarization means when action potential reaches a place, then depolarization takes place in that region. When the action potential is stopped, again, what will happen? It will fall from plus 30 to again minus 70, or in some cases below minus 70 also. So a drop will be there in the potential. So this drop is called as repolarization. So earlier polarization, now this thing depolarization, after depolarization, repolarization. So depolarized event and repolarized event, these two events will give a spike. Okay, this is first electrical event. So this first electrical event will take place in this motor end plate or in the ending of the neuron. So when this change is taking place in this thing, automatically in the T tubule or in the sarcolemma of the muscle fiber also, this potential differences will take place. So this is the second second electrical event that will take place in the muscle fiber. But there will be some gap, some time gap will be there in these two electrical events. First, this electrical event in the neuron end plate will take place. And after 1 millisecond of time, second electrical event will take place in the membrane of the muscle. Okay. Once this muscle fiber also is having this membrane differences or electrical events, then what happens from T tubule and cisternae, these calcium ions will be released. Calcium ions, they will go and they will bind with this troponin, and immediately tropomyosin will be moved away from the active sites of the actin proteins. Then myosin fibers will attach to the active sites and muscle contraction will take place. We have seen about all these things in the previous class. Okay. So due to these changes, what happening? Third event is taking place. That is mechanical event. So in the mechanical event, what is happening? Mechanical change is taking place. Earlier, the muscle fiber will be having a long structure. Due to this contraction, muscle fiber becoming short and thick. Earlier, it was long and thin. Now it is becoming short and thick. So this change in the muscle fiber structure, a change in the muscle fiber structure due to the contraction also produces some type of tension in the muscle cells. So that tension will be measured with this graph itself. With the help of graph, we can see the tension, how much tension has been generated in the muscle fiber. So that tension is depicted in this form of a spike. So this is third event, mechanical event. So when a single action potential is given to this nerve fiber, a single a single spike will be generated in the this machine. So this single spike is called as a muscle twitch. So muscle twitch is nothing but a representation of muscle twitch is the representation of a single contraction and relaxation. When the muscle fiber relaxes one time, when the muscle fiber contracts and relaxes one time, that one contraction and one relaxation is called as a twitch. So the single muscle twitch will be in this form. Okay, it will be in this form. So these are the three events that will take place in this muscle contraction, two electrical events, one physical event, or one mechanical event. Next, coming to the our topic, first topic, muscle twitch. So muscle twitch, as I have already told, it is a response of a muscle fiber delivered to a single action potential. When a single action potential is given to the muscle fiber, it will contract one time, and immediately after contraction is over, it will relax. So one contraction and one relaxation is called as a muscle twitch. So the muscle twitch starts about 2 milliseconds after the depolarization takes place on the membrane. Why? Because here, as we have seen in this graph, in this slide, so 2 milliseconds time will be there to finish the second electrical event in the sarcolemma. In the sarcolemma, the spike will take 2 milliseconds time. Once the 2 milliseconds type, or once the spike is finished, then only muscle contraction will start. So once the sarcolemma or membrane of the muscle fiber receives this second electrical event or depolarization, so this depolarization takes 2 milliseconds of time. Once this depolarization is finished, then only this muscle contraction will start. And the duration of twitch. So here in this slide, you can see that this duration, okay, this is the contraction phase, this is the relaxation phase in this muscle twitch or muscle contraction. So the duration of this muscle twitch will take place from takes a time of 10 milliseconds to 100 milliseconds, depending on type of muscle fiber. So there are two types of muscle fibers are there. These two types of muscle fibers, one is called as fast twitch muscle fibers, second one is slow twitch muscle fibers. Fast twitch muscle fibers take uh, a time of around 10 to 7.5 to 10 milliseconds of time to finish the twitch. So contraction and relaxation will be finished within a 7.5 milliseconds to 10 milliseconds of time in fast muscle twitch fibers. In slow muscle twitch fibers, the contraction and relaxation will be finished in 100 milliseconds of time. So these will contract, relax fastly. These will contract and relax slowly. So in our body, in our all skeletal muscle fibers, we will be having two types of muscles, fast twitch muscles and slow twitch muscles. So by doing some special exercises, we can increase the number of fast twitch muscle fibers, or we can increase some slow twitch muscle fibers also. In athletes, different these fast and slow twitch muscles will be developed differently. Say, for example, in fast sprinters, like some athletes will participate only in 100 meters running. In such people, fast muscles will be increased in number. So the fast muscles will help them in running short distances very speedily, in no less time, in less time they will run for the short distances. So in such athletes like 100-meter sprinters like Usain Bolt, in such people, fast muscle fibers will be increased, and they are very important for them. So by practicing the same event, they will increase fast muscle fibers. And in slow muscle fibers, this will be a high in number in marathon runners. In marathon runners, they need to run the distance of minimum 5 to 10 kilometers. In some races, 40 kilometers distance they have to run. So to run such long distances, if they have fast muscle fibers will get fatigued in no time. So they will get tired fastly. But slow muscle fibers, they take a lot of time to finish the contraction, so that they cannot get tired so easily. So marathon runners, they will improve slow muscle fibers. So that's why the athletes who participate in marathon runners, they will not participate in this 100 meters running races. Why? Because 100 meters runners, they require lot of fast muscle fibers. Marathon runners require slow muscle fibers. That's why a single person cannot participate in these two events. So this is the two types of muscle fibers, depending on the time of twitch that they will take. And the strength of the twitch also depends on the number of motor units activated. As I have already told, one motor unit consists of a single muscle fiber and a single nerve fiber that are connected to each other. So if many motor units are activated, lot of strength will be generated by the muscle contraction. So when you are doing a light work, only some motor units will be activated. When you are doing the hard work, almost all motor units will be activated in your muscles. Say, for example, let us imagine a situation where you are picking up a single paper. Okay, a single paper you are picking from the ground. So to pick that paper, you need very less energy. In such cases, only few motor units in your hands will be activated. Say in another example, for example, you are about to pick a 50 kilogram of weight onto your shoulder. So to pick to lift the 50 kilogram of weight and put on your shoulder, lot of energy is required. In such cases, almost all motor units present in your muscles of your hand will be activated. So the strength of that twitch depends on how many motor units are activated. And this is the graphical representation of a twitch. In a twitch, three phases will be there. One is latent phase or gap phase or lag phase. So latent period or latent phase, gap phase or lag phase. And in this latent phase, what will happen? It will take around 2 milliseconds of time. In this phase, gradually calcium concentration will be increased in the cytoplasm of muscle or sarcoplasm. So once the sarcoplasm in the once the calcium concentration in the sarcoplasm reaches the required quantity, then automatically muscle contraction will start. So once the calcium ion concentration reaches this threshold limit, muscle contraction period will start. So once the muscle contraction period is about to end, then what will happen? All the calcium ions again they will go back into triad system or T tubules and cisternae. So then automatically relaxation period will start. So third phase is the relaxation period. So once the relaxation period is stopped, again gap period or latent period will be there for the second muscle twitch. And out of these three phases, this will occupy very less time, latent period, and the contraction period will be occupying or will be taking moderate time, and relaxation period will take lot of time. So this is the single muscle twitch. And coming to summation. So summation is that when only one stimulus is given. So see, carefully observe this slide, this graph. When only one stimulus is given, one stimulus means one action potential is given to the muscle fiber, a single twitch will be generated. We can see that single twitch in this form on the graph paper. What if a second stimulus is given before the first relaxation is finished? Before the first relaxation is finished, if the second stimulus is given, what will happen? Due to the second stimulus, much more calcium ions will enter into the sarcoplasm. So then what will happen? This relaxation will not occur immediately. Second contraction will take place. So why? Because due to the first stimulus, some amount of calcium entered into the cell. Before all these calcium ions sent back into the T tubule or triad system, so due to the second stimulus or second action potential, much more calcium ions entered into the cell. So when much more calcium ions are there in the sarcoplasm, what will happen? Further second contraction will take place. So the graph of a two stimuli given successively rapidly will be like this. Okay, so this is called summation. Summing means, adding up or joining with each other to give a maximum effect. So when the two or more stimuli are given in succession, in a rapid succession, fastly, one after the other, without giving any chance to this contraction phases to occur, then what will happen? The muscle twitching will be like this, and the effect of muscle twitch, the generated strength will be increased. So that is called as summation. So the tension developed during the summation will be greater than a single twitch. Why? Because in a single twitch, only few calcium ions will be entered into the sarcoplasm, and only some amount of strength will be generated. But due to the summing effect, lot of strength will be generated when summation will take place. And summation forms of two forms of summation are there. One is summation of stimuli, another one is summation of contraction. So when the summation is taking place by successive stimuli, this is called as summation of stimuli. Say, for example, to this muscle contraction happen, some certain threshold value is there. So when 100 millivolts of stimulus is given, then only as 100 millivolts of stimulus is given, then only muscle contraction will be taken. So that is called as threshold value of that stimulus. Say, for example, we have given only one stimulus. That stimulus is having only 50 milliseconds of capacity, but successively, immediately, we have given another stimulus. So due to the summation of the stimulus, Even though individual stimuli are not having threshold value, but due to the summation of this low capacity stimulus, if the muscle contraction takes place, that is called as summation of stimuli. Okay, in this case, individual stimuli are not capable of producing muscle contraction, but due to the summation of very weak stimuli, okay, due to the summation, all these weak stimuli are able to produce muscle contraction. That case, it is called as summation of stimuli. In another case, summation of contraction. In this case, each stimuli is capable of producing muscle contraction, as we have seen in this slide. If this happens, this is called as summation of contraction. And the summation of contraction is of two types. One is temporal summation, another one is spatial summation. In temporal summation, this slide is example for temporal summation. In this, what happening? First stimulus is given. Immediately after some time, say for example, 1 or 2 milliseconds of gap is there in between second stimulus. So if the time gap is there in between, some time gap is there in between the successive stimuli, that is called as temporal summation. In this thing, in temporal summation, what will happen? The summing up of the same motor unit can be seen. And second one is spatial summation. In spatial summation, what will happen? All the stimuli will be given at the same time, but to different motor units. Okay, as we have seen in this first slide. Okay, what is motor unit? Motor unit is a single fiber connected to a single neuron is a motor, single nerve fiber is a motor unit. So like this, in our fascicles, in our muscles, we are having many motor units. If all the motor units are stimulated at the same time, all the muscle fibers will contract at the same time. That will produce lot of strength in the muscle fiber. So that is called as spatial summation. So summation is taking place at the same time, but not in the same motor unit. All the motor units are becoming activated. All the motor units are participating in the muscle contraction. So that's why different motor units present in different places. Okay, two motor units cannot be in the same place. So okay, so that's why they are spatially arranged. So spatially arranged motor units, many motor units, if they are activated at the same time, that is called spatial summation of muscle contraction. So these are the two types of summation of contractions. And summation of two successive stimuli, how it will take, let us imagine. So say for example, this is the response of the a muscle fiber to the stimulus. This is a response of a muscle fiber to a single stimulus. If the second stimulus is given before this, in this first half of the latent phase or first half, so the latent phase will have two subphases. One is first half phase. This blue color one is second half phase. If the second stimulus is given in this first half of this latent phase, then there will be no effect. Why? Because the muscle contraction or nerve impulses action potential will follow all or none law. All or none law. So if the two stimuli are given at the same time, the same single twitch will be arisen, but not the increased twitch or increased strength will be, no increased strength will be generated if the two stimuli are given at the same time or in the first half of the latent period. Say if the second stimulus is given in this first half, then also there will be no response. Same response will be there. Response will not be in increased form. If the second stimulus is given in the second half of the latent phase, in this second half, in this blue phase, if the second stimulus is given, some increase will be there in the successive response. And if this thing, if the second stimulus, if it falls in the during this contraction phase, if the first stimulus is generated this contraction phase, in this time, if the second stimulus is given, as we have seen in this previous slide, like this, the increased response will be there. So increased response will be seen in this second stimulus if it is given in this contraction phase. So if the second stimulus, if it is given during the relaxation phase also, before the relaxation is finished, if the second phase is second stimulus is given in this last phase also, increased response will be seen. So this is the summation of two successive stimuli. And the reasons for this beneficial effect of this summation is because release of more calcium ions into the sarcoplasm from sarcoplasmic reticulum. So due to the second stimulus, due to the second action potentials, lot of calcium ions will be entering into the sarcoplasm. That's why the beneficial effect is taking place. And this also due to increase in the temperature of muscle fiber, and due to the second stimulus given fastly, there will be a decrease in the internal viscosity and resistance of the muscle fiber. Due to this reason, also the beneficial effect is taking place, and decrease in inertia of the recording system. So inertia also will be decreased due to this successive stimuli. That's why this benefit effect or increased responses can be seen. And genesis of summation. So genesis of tetanus. So the summation finally results in the summation effect. So if you see this graph, four situations are there. Actually, five situations are there. So this is a single twitch. If the muscle fibers are given, if the stimuli are given successively, we can see a staircase effect. Or this situation is called Treppe. And this is summation, as we have already seen summation, how the summation is taking place, what are the regions. And finally, if the stimuli are given very rapidly, finally we will get a tetanus condition. In this tetanus condition, what will happen? Muscle will be in contracted form only, no relaxation will be taken place. So this tetanus condition is of two types. One is incomplete tetanus, this is incomplete tetanus, and this one is complete tetanus. So finally, due to this increased effect of this summation, finally we will be having tetanus condition. So to occur this tetanus condition, first of all, staircase effect will be there. Later, this incomplete tetanus, finally complete tetanus will be there. So how this tetanus condition will be generated, let us see. So first one is staircase phenomenon or trip. Okay, staircase phenomenon or trip. In this staircase phenomenon, what will happen when a series of stimuli are given to the muscle fiber? Tension will be increased during each twitch. So after several contraction, what will happen? A uniform tension per contraction will be reached. So due to this reason, the graph will be appeared in a staircase phenomenon. The graph will be seen in a staircase format. So this is called as Treppe. And some people who participate in this running events, they will do in the beginning of this event, they will do some warming up. So due to this warming up of muscle, all muscles will be reaching this maximum strength. That's why they can perform very well in that competition. That's why before doing, before participating in this athletic events, the athletes will do warming up. So the basis for warming up is this phenomenon of staircase or phenomenon of Treppe. And Treppe is believed due to the increased availability of calcium for binding to troponin and accumulation of heat or effect of pH. Due to this reason, Treppe effect will be taking place. And this occurs in cardiac muscle also. But these cardiac muscles, they cannot be reached tetanized condition. If tetanus is taking place, contraction will be sustained, no relaxation will be there. If there is no relaxation, the problem will be arisen due to this muscle, heart muscles, they need to contract and relax continuously. And this in this case, we can see that this is the response of this first stimulus. And due to Treppe event, what is happening? Second stimulus giving some more increased effect. Gradually, what is happening up to this phase 1, 2, 3, 4, 5, 6, 7, up to 8 phases, gradually the response of each individual stimuli will be going to increase. So this is called as Treppe. After Treppe is taking place, then finally what is happening? All these things are uniform in capacity. So this is tetanus condition. So first to tetanus to occur, the muscles will go through a Treppe period. So in Treppe period, what is happening? First muscle contraction gives a complete twitch. So this relaxation also will be done. After relaxation is being done, second muscle contraction will start due to second stimulus. But due to the availability of more calcium ions, the tension will be increased. So continuously, this will take place up to certain period. So this is giving the staircase effect. This is called Treppe. And another one is clonus. In clonus, what is happening? It is similar to Treppe only, but in this case, what is happening? Muscles will not relax completely. So if the muscles relax completely, this graph come to here up to here, but it is not coming. So before the muscles contract completely, second response is given. So this is giving a gradually increased effect. So there is a small difference between Treppe and clonus. In clonus, muscles are not relaxing completely, but in Treppe, muscles will completely relax. After relaxation, seconds contraction will take place. So this is the difference between clonus and Treppe. And in this thing, how the summation is taking place. So this is single twitch summation. In summation, we have seen this Treppe condition. Next, incomplete tetanus, complete tetanus. So when the rapidly these stimuli are given to the muscle, it will finally reach this tetanus condition. All individual responses fuse with each other to continuously contract. So this contraction of continuous contraction is of two types. One is complete tetanus, incomplete tetanus. In incomplete tetanus is also called as unfused tetanus. It is also called as unfused tetanus. In this second stimulus will be given before this relaxation is finished, so that this a gradual increase will be there in this incomplete tetanus or unfused tetanus. But in fused tetanus, what will happen? Before the first response goes into this relaxation phase, second response will be given. So due to this region, completely it will be straight or plateau stage will be reached in the muscle. So this plateau stage gives the muscle to be completely infused or in completely this what contracted phase. So no relaxation will be there. So if this is happening, we cannot move our hands. The hands or our muscles will be in completely this what contracted phase only. This is called complete tetanus. And complete tetanus is not good for our health. Why? Because tetany is also a disease condition. This occurred due to this some bacteria, Clostridium tetani. So if it takes place for a longer period of time, death also may be occur. In our skeletal muscle fiber, some period of time, it may arise like this. When we are doing a hard work, in some cases, we will be not able to move our hands from contract state to a relaxed state. Why? Because that is due to this tetanus only. So in tetanus, all the stimulus, successive stimulus will be given before the previous stimuli lets the muscle to enter into what relaxation phase. So that's why this complete plateau stage will be there, and the strength generated in this tetanus will be higher than any other incomplete tetanus or clonus or Treppe condition or single twitch. So when compared to remaining all effects, the effect of the capacity of or the strength of this complete tetanus will be high. And in this thing, we can see that single muscle twitch we have seen in the previous slides. This is the Treppe condition. In Treppe condition, the first response lets the muscle fiber to go into complete relaxation. So complete relaxation will be there in each stimulus, but due to the lot of calcium ions are available in the muscle fiber, with each successive stimulus, lot of capacity, lot of strength will be generated. So this is giving a staircase effect. This is called Treppe. In clonus, what is happening? The muscles are not completely relaxing. So this is also look similar to Treppe condition, but in Treppe, muscles are relaxing completely in each stimulus, but in clonus, muscles are not completely relaxing. In incomplete tetanus, what is happening? After clonus, first Treppe will be taken place, then Treppe results in the clonus condition, then after clonus condition, muscle enters into incomplete tetanus. After incomplete tetanus, finally muscle enters into complete tetanus. So in this thing, in this incomplete tetanus, relaxation period will be highly decreased when compared to clonus condition. So in complete clonus condition, no relaxation will be there. So from this region to this region, this is complete tetanus condition. Here, so you can see this zigzag-like structure. This zigzag-like structure is incomplete tetanus. Okay. So this is about the tetanus, and final topic is fatigue. Fatigue is nothing but a temporary reduction of the working capacity of the muscles. So in this condition, muscles are not able to move. They cannot contract. They cannot. They will be in relaxed phase only. So no muscle contraction will take place. That is called as fatigue or tired condition. So the muscles will be in a tight condition, that is called as fatigue. So, and this fatigue is a reversible phenomenon. After taking some rest, this muscle fatigue will over, and again muscle will be able to contract. The effects of muscle fatigue is that muscle ache, pain will be there in the muscles, burning sensation, a rapid breathing. When the muscles are in fatigue state, we will be breathing lot of oxygen. Why? Because to give it back, to bring it back to the normal position, muscle cells require a lot of oxygen. And nausea and stomach pain conditions also can be encountered during this thing. And the causes of this muscle fatigue is ionic imbalance within the muscle cell, nerve fatigue and loss of desire, metabolic fatigue, lactic acid accumulation, exercise and aging. And ionic imbalance in this thing, in some disease condition, in some persons, calcium ions cannot bind to this troponin, and due to this less availability of calcium ions, so that this ionic imbalance, so required quantity of calcium ions are not available. That's why the ionic imbalance will take place, that results in this easily fatigue condition. So they will get tired easily due to ionic imbalances. And nerve fatigue, nerves also will become fatigue. Why? Because due to continuous supply of action potential, they become tired. That also results in the delay of this action potential supply. And loss of desire also. When we feel mentally tired also, due to that reason also, muscles will get tired. And metabolic fatigue, in metabolic fatigue, some metabolites like magnesium ions are also required for this calcium ions to be released from this triad system. So magnesium ions are required for the release of calcium ions. When magnesium ions are reduced in this thing, calcium ions are in required quantity, but magnesium ions are not in required quantity. So this is called as metabolic fatigue. And due to heavy exercises and due to aging factors also, this muscle fatigue will take place. Due to exercises, what will happen? Lot of lactic acid will be accumulated in the muscle fiber. When lactic acid is accumulated, that results in this fatigue condition. And lactic acid need to be oxidized, for that oxygen is required. That's why only when we are in fatigue condition, lot of increased respiratory rate will be there. So these are the causes of the muscle fatigue. So with this, today's topic is over. We'll meet with another topic in the next class.